Hello everyone, welcome to our channel Foodtech Spy. In today's video, we are going to see blanching. So blanching is a mild heat treatment and it is said to be a pre-treatment. Now pre-treatment means it is done prior to some major processing techniques like maybe canning, it can be done before freezing or drying. So it is called as pre-treatment. And usually blanching is done at 74 to 100 degrees Celsius. Sorry, 70 to 100 degrees Celsius. So what is blanching? So basically blanching is exposing your food product to hot boiling water or steam and immediately transferring it into ice water, cold water or cold air. So the reason for immediately transferring it into ice water or cold water is to stop cooking or to avoid cooking. Now, what are the purpose of blanching? So first purpose of blanching is to inactivate the enzymes. Okay. So blanching is mostly done for fruits and vegetables, we know. So fruits and vegetables have n number of enzymes like polyphenol oxidase, they have catalase enzyme, they have peroxidase enzyme and many more like chlorophylase. But what all these enzymes do is they cause loss of your color, loss of flavor, loss of texture as well as nutrition. And to retain this color, flavor, texture and avoid loss, we have to inactivate the enzymes. Now, among these also, catalase and peroxidase are most heat resistant enzymes, okay? These are the most heat resistant enzymes. They are considered as marker enzymes. Marker enzymes means they determine whether you have done blanching adequately or not. Then other purpose of blanching is to reduce microbial load on surface of food. Now, whenever you are harvesting any kind of fruit or vegetable or any kind of food, we know surface of that fruit or vegetable has n number of microorganisms, pesticide residues, contaminants, toxic residues, and to remove those, blanching is done. Okay. Then other purpose is it softens vegetables for easy filling into containers. So in blanching, fruits and vegetables are softened, which makes it easy to fill into containers, mostly during canning. Okay. And then removes intercellular air, which increases density of food and helps form headspace vacuum in cans. Now here mainly we are again talking about canning only. So in canning, what happens? Suppose you have a can and you have food in it. So food has intercellular air. Okay. And when we do blanching, this intercellular air is being removed. Okay. And when it is being removed, your food turns out to be more denser and more compact and helps form headspace vacuum. This headspace vacuum is very important because it holds your lid very tightly. Also, one more thing it does is it prevents entry of microorganism as well as air, okay, which also prevents oxidation. So these are the purpose of blanching. So there are two main types of blanching, hot water blanching and steam blanching. First, we are going to see about steam blanching. So steam blanching is done for foods with large area of cut surfaces. And most common design of steam blancher is tunnel steam blancher. In image you can see this is a tunnel steam blancher. So this tunnel steam blancher is nearly 15-meter wide and it is 1 to 1.5 meter, sorry 15-meter long and 1 to 1.5 meter wide. Inside this tunnel blancher you have a conveyor belt on which your food is kept or placed and then it is carried through a steam environment, okay, and it is blanched. So steam blancher has one advantage like water soluble components are retained because we are using steam, water soluble components are not lost, okay. But there is one disadvantage also, like for example you have a conveyor belt and you have piled up food too much. So what will happen, it will take too long to heat to reach at center, and because of which the food which is at bottom or which is at outer layers, it will become overcooked or it will be overheated. So this is one of the disadvantage. So to overcome this advantage of overheating or overcooking, we have one system called IQB, that is individual quick blancher. Now, individual quick blancher, what is different in this is it here the food is heated in a single layer. Okay. So first section here, it has three stages. First, here food is heated in a single layer so that heat spreads evenly and reaches center immediately. Second, adiabatic holding. Here food is holded in an insulated bed so that heat spreads evenly and it reaches center very fast. And then your food is cooled. Okay. So this is how IQB works. And there are few advantages of IQB, like it helps retain your vitamins, like vitamin C is retained, some other vitamins are also retained. Then minimal weight loss is there, and also complete enzyme inactivation is there. The next is hot water blanching. We all know the temperature of water is 70 to 100 degrees Celsius, and most commonly used design in hot water blanchers are reel blancher. So reel blancher has rotating drum. Here it is drum. It has rotating drum. You can see in the image, which is partly submerged into water. Here below it is a water. So it is partly submerged into water and food is placed inside this drum. And food is carried with help of internal paddles. Okay. And this is how it is blanched. Another type of design is pipe blancher. So pipe blancher basically has a long metal pipe, insulated metal pipe, which has hot water inside it. And inside this your food is carried. Now mostly it is used for packed food. This is how pipe blancher works. And there is one more system as like IQB, which is called as blancher cooler system. It also has three stages, same like heating, blanching and cooling. The only difference is here heat exchanger is used. Heat exchanger is used to reuse heat between these three stages, heating, blanching and cooling, so that 70% of heat can be recovered. Then let's see effect of blanching on food. So first is effect on nutrients. Now some of the minerals, water soluble vitamins mainly, and other nutrients are lost during blanching due to three main reasons. First is leaching. Leaching means some of the water soluble vitamins or minerals, they solubilize in water and then they are carried along with that hot water. So that is leaching. Then heat damage because of temperature what we are using, and oxidation. Okay. So one more thing is ascorbic acid is used as indicator of blanched food quality. So if more amount of ascorbic acid is retained, that means quality of your blanched food is very good. Then next is effect on color. So blanching eventually improves the color of foods. How it improves? Because it removes air and dust on the surface. This changes how the light reflects. Okay, and because of that color is improved. Now, in green vegetables, we all know there is a pigment called chlorophyll in green vegetables, but this chlorophyll pigment can be lost during blanching. So, to avoid that loss, sodium carbonate or calcium oxide is used in blanching water. That helps retain chlorophyll. But there is one disadvantage. This sodium carbonate and calcium oxide raises the pH, because of which again vitamin C can be lost. One more thing in color is some of the fruits and vegetables, like we know, like potatoes, okay, then bananas, mainly potatoes, apples, they turn to be brown because of enzymatic reactions, mainly polyphenol oxidase. So to avoid that, before blanching, they are holded into a brine solution, okay. The next is effect on flavor. So, if you do proper blanching, your flavor remains unchanged. But if you are doing under blanching, you are doing blanching for lesser time than required, then it causes off flavors during storage. Okay. Then next is effect on texture. So we all know blanching softens vegetables and fruits and it makes canning easier, like sealing it into can easier. But in some processes, like if you do blanching before freezing or drying, it can overly soften some foods, which is undesirable. So to avoid that, 1 to 2% of calcium chloride is used. And what this calcium chloride does is it causes it like it makes calcium pectate. It forms calcium pectate in your fruit or vegetable, whatever food is there, and it helps to keep it firm, like it maintains the texture. Then next is tests to determine blanching adequacy. So we all know catalase and peroxidase are marker enzymes. So first test is about catalase. So in catalase test, hydrogen peroxide solution is added to blanched sample, okay, and then it is observed for effervescence, means oxygen bubbles. Now if there is strong effervescence, like oxygen bubbles are coming for 2 or 3 or more than 3 minutes, then it means that catalase is present and you have not done blanching properly. Blanching is done inadequately. But if there is no effervescence, there are no oxygen bubbles, very weak effervescence, that means your catalase is inactivated and you have done blanching properly. Then other test is peroxidase test. In peroxidase test, glycol solution and hydrogen peroxide solution is added to blanched sample and then it is observed for color change. Now here, what are the interpretations? If color is developed, if red or brown color is developed, that means still the peroxidase enzyme is present and you have not done blanching properly. But if no color develops, peroxidase is inactivated and blanching is done adequately. So that's for blanching. Thank you.